Today I'm going to share a solution for a problems on leet code, the 233 problem, number of digit 1. So here is the description of the problem. Given an integer n, count the total number of digit 1 appearing in all non-negative integers less than or equal to n. For example, giving an integer 13, we should output 6 because from 1 to 13, 1, 10, 11, 12, and 13, those 6 numbers contain digit 1, so we should return 6. So here is the solution, which is trying to find the patterns so we can solve this problem more efficiently. So intuitively, like, we can just iterate from 1 to n and check if those numbers from 1 to n has a digit 1 or not. Then we return this count, but that is not efficient. So here is a solutions which utilize a pattern. So I'm going to talk about what the pattern is. For example, giving an integer 1, 2, 3, 4, right? So we can count the total number that contains 1 in the following way. First, we only need to look at the lowest base. So the number in the lowest base. So we look at the number 4. So in the number 4, there are only like 1 numbers that contains digit 1, which is 1, right? And then we look at 34. So for 34, you can count the total number of that contains 1. You can count this number in two steps. The first step is you only look at the first base, which is 4. So you check how many numbers from 1 to 4 that contains digit 1. So we already know, like, from 1 to 4, there is only one digit, one number that contains digit 1, right? So it is only 1, and then as long as the digit in the first base is 1, then no matter where there is which digit in the second base is, we should count that number, right? So it's like if this digit is if this base has digit 1, so then 11, 20, 21, 31, they are all contains digit 1. So we should count these 3 numbers, right? So the first part is like, in the second base we have 3. So we times the number of numbers that contain digit 1 in the first base, so which is 3 times 1. And then the second part, we should consider, like, in this second base, if you um, if you above if this number 34 is above 10, right? So from 10 you will have 10 11 and 12 to all the way to 9 all the way to 90 all the way to 990. They all have they are the numbers that contains digit 1 because the first because the first because the first because the digit in the second place is 1. So there are in total 20 numbers, right? So for 34 you will have in total 23 numbers. After that we continue to consider 234. So we follow the same steps as we do for the 34. We first calculate how many number of digits that contain digit 1 in 34. Then we use time. We use this digit the digit in the third base, which is 2 times. I use a function f to present how many number of digits contains how many numbers contains digit 1 from 34. And the second part is like even the third base has digit 1. So how many numbers can start with 1? So which has 3 digits in total. So it is 100, right? From 100 to 101 and 102, all the way to 199. So there are in total. There are in total 200 numbers, right? No, sorry. In total, there are like 1,000 numbers. 100 numbers, sorry. Because from 1 to 199. Yeah. So it's 100 numbers. And above, so I made a mistake from 10 to 19. So there are in total 10 numbers. So here is 13. Alright. So we do the same thing for 1,234. First part, you need to like count the numbers that has digit 1 from 2, 3, 4. And the second part, which is a little different, because if the first digit is 1, then you cannot count from 1,000 all the way to 1,999 because they only has 234. So for the second part, you can only count from 1,000 to 1,243, which has in total 235 numbers. Alright, so in the end, you add all those numbers together. That will be the answer for the 1,234. Yeah, that's the basic idea. if you after you know the ideas and you can read the code again, I think you will be able to understand what does this code mean. Okay, thanks for listening.